right, so here are the rest of the notes on exponents. We have two more properties to cover that we have not covered yet. And before we start, we're going to look at a little pattern I have made here. So, here's what I would like you to notice. Over here on this side of the column, I would like you to look at the exponents and see what the pattern is for the exponents. And clearly, I think you'll agree that the pattern is that the exponents are going down by 1 each time. All right, 2 to the 5th, 2 to the 4th, 2 to the 3rd, and so on. And what is the pattern over here? Well, in this column, the pattern is that as I move from one term to the next, I am dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8, and so on. And that kind of makes sense because as the exponent goes down by 1, I am losing one of the 2's each time, and so that's kind of like dividing by 2 to get the next number. So I think we'd all agree that 2 to the 3rd power is 8, 2 times 2 times 2, and 2 to the 2nd power is of course 4. And we all know that if we keep dividing, then this one would need to be 4 divided by 2, which is 2. And I think we all knew that 2 to the 1st power is 2. The next one here is where it really starts to get interesting. A lot of students think that 2 to the 0 power would be 0. But in fact, it's 1, right? Because to continue this pattern, you would divide by 2 again, and 2 divided by 2 is 1. So if we're going to follow the rules of math and the patterns of math, 2 to the 0 power needs to be equal to 1. And the same thing would happen with the tens over here, except in this case, we're dividing by 10 each time. So 10 to the 2nd power is 100. And then 10 to the 1st power is 10. And then, of course, when I divide by 10 again, 10 to the 0 power is 1. And so this is kind of the first interesting case, is that no matter what you have to the 0 power, it equals 1. So let's go ahead and write that rule in. That is called the zero exponent property. And it says any non-zero number, so the only thing this does not work for is the number 0, to a power of 0 is 1. 5 to the 0 would be 1. Even a variable like x to the 0 would equal 1. And if this was in a book, there would probably be some type of disclaimer saying x cannot equal 0. Because if x were 0, you'd have 0 to the 0 power, and that's kind of undefined. All right? But anything else, any non-zero number equals 1. So even if I have something like pi, pi to the 0 power would be 1. If I had a whole bunch of stuff like 3x squared y, all to the 0 power, it would equal 1. The one that sometimes gets students is when you have something like 7x to the 0. And that does not equal 1 because that's really like 7 times x to the 0. And the x to the 0 equals 1, but not 7. So you get 7 times 1, and that's 7, right? All right, so that's the 0 power. The 0 power is an easy one. Anything to the 0 power equals 1. Let's go back to our patterns. So now is when it gets really interesting. When I divide by 2 again, what's 1 divided by 2? And let's keep it as a fraction. Well, that would be 1/2. And that, in fact, is what 2 to the negative 1st is. And in fact, if I wanted to go one more and do 2 to the negative 2nd, I would be dividing by 1/2 again, or by 2 again. What's 1/2 divided by 2? Well, that's 1/4. And 2 to the negative second actually is equal to 1/4. And I think I'd like to show you how this works a little bit. So over here, 2 to the negative first is equal 1/2. 2 to the negative second is equal 1/4, or 1/2 squared. And if I went one more, 2 to the negative third would be equal to 1/8, or 1/2 to the third power. This is what I would like to point out to you. A negative exponent does not cause the answer to be negative, because really I'm just dividing by 2 every time. And when I divide by 2 every time, that doesn't turn the answer negative, right? It kind of turns it into a fraction. Technically what it does is it makes you take the reciprocal. Remember that this number here that's under the exponent is called the base. And when you have a negative exponent, what you actually do, a negative exponent causes you to take the reciprocal of the base. The reciprocal of 2 is 1/2. And when you take the reciprocal of the base, that turns the exponent positive. So this -1 here turns into a +1. And I get 1/2 to the positive first. Or in this case, when I take the reciprocal of the base, I get 1/2, and this -2 turns into a +2. Taking the reciprocal of the base turns the exponent positive. All right, let's keep that in mind as we move forward. So, when you have a negative exponent, your job is to simplify it. And you simplify it by changing them into positive exponents. Right? If you read that next line, simplified expressions never have negative exponents left on them. Right? You're not allowed to have a negative exponent left on your answer. You must turn it positive. All right? So the goal with negative exponents is to turn them positive, then apply them perhaps. All right? So here, right, never have negative exponents. There are 2 ways to change a negative exponent into a positive one. Okay, really there's just one way, but there's 2 ways to think about it. Taking the reciprocal of the base is how you turn an exponent positive. All right, do you remember what reciprocals are? Like 2/3 and 3/2. Right? A reciprocal is just a fraction flipped over. The act of taking the reciprocal of the base turns the exponent from negative into positive. And by the way, that would work the other way also. Could turn it positive into negative, I suppose, if you wanted to take the reciprocal. So we're going to look at some examples here. The first example I'm going to look at is x to the negative second. Now, if I had x to the negative second, how would I simplify that? Well, because it has a negative exponent, I would want to take the reciprocal of the base. The reciprocal of x is 1/x. Right? You can think of x as a fraction by putting it over 1, and then its reciprocal would be flipping over the fraction. And when you flip the fraction over, that turns the exponent positive, and you're really done. 1/x squared is the simplified version of x to the negative second. Let's try another one. what if I had a squared times b to the negative third? Well, again, you might want to write those as fractions. Technically, that would be a squared over 1 times b to the negative third over 1. But because you have a negative exponent here, you're going to need to take the reciprocal of that and turn it positive. So this would actually equal a squared over 1 times, and this guy would take the reciprocal, which would be 1 over b, and that turns the exponent positive. And then finally, when you multiply those together, you get a squared over b to the third, right? A squared times 1 is a squared, and 1 times b to the third is b to the third. Now, in my opinion, well, I'll get to that in a minute. Let me show you one more interesting example, I feel like, if I can remember it. What if I had x to the third times x to the negative third? Now that's interesting. We're going to do this one twice. So the first time we do it here, we're going to do it the easy way. The easy way would be to use an exponent rule that we learned last class, and that is when you're multiplying terms together, you add their exponents. What do we get when we add 3 and negative 3? Well, we get 0. And what is anything to the 0 power? It's 1. This equals 1. Let's see if it equals 1 when I use reciprocals. So over here, I would want to take the reciprocal of this, and I would get x to the third over 1 times 1 over x to the third. Right? So I took the reciprocal of x, and that turned the exponent positive. And then when I multiply these together, I get x to the third times 1 is x to the third. And 1 times x to the third is I get x to the third over x to the third. And when you divide something by itself, what does that equal? It equals 1. Same answer. All right. I have one more example that I think we'll find interesting before we move on, and that is this. What if we had x to the negative second over y to the negative third? And I wanted to simplify this. Well, the first thing I would want to do is turn those negative exponents positive by taking their reciprocal. So, what is the reciprocal of x to the negative second? Well, that would be 1 over x, and it would be to the positive second, right? And what is the reciprocal of y? Well, that would be 1 over y, and now it would be to the positive third. So now I have this crazy looking fraction, and this crazy looking fraction is what we call a complex fraction, because it's a fraction that has a fraction in the numerator and the denominator. And how do we simplify that? Well, if you remember, a fraction bar here just means divide. This is really equal to 1 over x to the second divided by 1 over y to the third. All right, so I've got this complex fraction, but really that's just a division problem. And so how do we divide fractions? You remember that? We keep, change, flip, right? So when I change this, when I try to divide this fraction, I would change it into a multiplication problem and make it 1 over, oops, let me do that again, 1 over x squared times, And I would flip the second one and make it y to the third over 1. And finally then, I can go ahead and multiply, and my solution would be 1 times y to the third is y to the third, and x squared times 1 is x squared. Now, that's a lot of work to do. What I would like you to look at is the fraction that we started with and the fraction that we ended with. And I would like you to notice that when you have negative exponents within a fraction, right? So I have these negative exponents within a fraction, that when I take the reciprocal and I do all the math, all that really happens is the y to the negative third that was on the bottom became y to the positive third on top. And the x to the negative second that was on top became x to the positive second, which is on the bottom. So often we will have negative exponents that are on fractions. And the thing I would like to point out to you is that taking the reciprocal is actually the same as just moving a term to the opposite place in the fraction. So if it's in the numerator, you move it to the denominator, and that's like taking the reciprocal and turns the exponent positive. Or if it's in the denominator, it moves to the numerator. And that is the rule that I have written here. All right? Moving the base with its exponent to the opposite place in the fraction turns the exponent positive. It's just like taking it actually is taking the reciprocal. I just don't need you to show all of this work. We're just going to take terms that are in a fraction and we're going to move them to the opposite place in the fraction. All right, so we're going to practice a little bit of this. It can be a little bit tricky. So here I have a fraction, and I want to simplify it. Now you might remember that the first thing is I need to simplify the coefficients, the 5 over 15. And 5 over 15 reduces to 1 over 3. But what I really want you to pay attention to here is the variables. I have this x's on top that have a negative exponent. So what they need to do is move to the bottom. But look, the x's on the bottom, so they're not there anymore, right? The x's on the bottom have a positive exponent, so they're going to stay there. So my final result as far as the x's go is all 5 x's, right? 3 on the bottom plus 2 more that I moved to the bottom. All 5 x's end up on the bottom. Let's look at the y's. The y's have these negative 3 on top. And as we've just seen then, I can move that to the bottom and that turns the exponent positive. So now I actually have a y to the third on the bottom instead, and those aren't there anymore. And I have this y to the negative first on the bottom. Now, that's also a negative exponent, and I need to turn it positive. So it would move to the top, and it would not be there anymore. And then I need to use my skills from the last class we had and cancel out the y's, right? I have 1 y on top, and I have 3 y's on the bottom. So when I go to cancel out the y's, I'm left with 2 y's on the bottom. And finally, that brings me to the z's. So the z's don't have any negative exponents. I just need to cancel them out. I have 1 z on top, and I have 4 on the bottom. So when I go to cancel out the z's, I can cancel out one of them, but the other 3 are still there. That'd be z to the third on the bottom. And my final answer is 1 over 3x to the 5th y squared z to the 3rd. Okay, the important thing there is you understand what do you do with the negative exponents and then cancel out your variables. Let's look at example B. Example B has a negative exponent on top of the fraction. So this guy needs to go to the bottom. And when he goes to the bottom, he's going to join the two x's that are already down there, and it's going to give me 7 x's on the bottom, right? The 2 that are down there and the 5 that move down there and turn positive. All right, so what's left over on top? Well, it doesn't seem like there's anything left over on top, but there's the coefficient. The coefficient here is 1, and the coefficient stays, so what you actually end up with is 1 over x to the 7th. Let's look at example C. All right, example C is similar to this example we did on the front right here. All right? But I'm going to show you how to do it, in my opinion, a better way now. I'm not going to want to write out this multiplication problem. Instead of writing out that multiplication problem, I like this method we use on the back much better. I look at this thing and I say, all right, I'm going to make it a fraction by putting it over 1. You could do that mentally, or you could do it physically like I just did and write the 1. And then I'm going to take this term that has a negative exponent, and since it has a negative exponent, it needs to move to the bottom and turn the exponent positive. So the b to the 7th is going to stay on top, but the a moves to the bottom and becomes a to the 5th, and you're done. Letter D. All right, letter D is one where I would actually use the reciprocal instead of moving it to the opposite place. I mean, I really just have one term, I have a 10, I take the reciprocal of 10, which is 1 over 10, and that turns the exponent positive. So 10 to the negative 2nd is equal to 1 over 10 to the 2nd. Or I could go ahead and simplify that and make it 1 over 100. Letter E. This is another one where I would go ahead and take this thing that's got a negative exponent and move it to the top. And that gives me 7 2's on top and nothing left over on the bottom. So this would just be 2 to the 7th. What is that, about 128 maybe? Let me show you also how that, just for fun, look how that also works with our quotient rule. Remember, when you're dividing things with the same base, you can actually subtract the exponents. So this would be 4 minus negative 3. And 4 minus negative 3 is also 2 to the 7th. So subtracting the exponent rule would work there also when you're dividing. Same answer. And last up, I have F. So F is just like A. Why don't you pause for a minute and see if you can get the answer, and then continue and see if you got it. So hopefully what you did is you took the 25 over 20. Now that negative sign is not an exponent, it's just a negative sign. And when you reduce 25 over 20, you get 5/4. It'd be negative 5/4. And how did you handle the variables? That's the big question in my mind. How did you handle the variables? So the x's, I'm going to erase this so we can see it better. The x's, I have 3 on the bottom, but these guys need to move to the bottom. All 7 x's should end up on the bottom. Did you get that right? How about the y's? So the y's have 3 on top. Oops. But they have this negative 1 on the bottom, and that needs to move to the top. So all the y's end up on top, and there'd be 4 of them. The z's, however, the ones on the top need to move to the bottom, the ones on the bottom need to move to the top. So what you actually end up with is z to the 7th on the bottom and z to the 10th on top. And then when you reduce, you'd have 3 left over on top. Z to the 10th on top. How'd you do on that? I hope you did okay. I've got 3 quick examples. Again, you might try them on your own before I do them. This first one, I would put it over 1. I would take the a to the negative 3rd and move it to the bottom. And the 5b squared would stay on top. And now I'm done. Here, since I just have a single term, I would take the reciprocal of x, and that would turn the exponent positive. And here, since the n is on the bottom, I would move it to the top, and I would have n to the 3rd over 1, or just n to the 3rd. All right, last up, I want to do a quick little story problem to show you how this might impact a story problem. I have a population of marine bacteria that doubles every hour under a controlled laboratory conditions. Bacteria doubles every hour. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Estimate the expression for h equals 0, 3, and negative 2. All right, so when h equals 0, I would have 1,000 times 2 to the 0. But 2 to the 0 is just equal to 1. So this would be 1,000 times 1, or 1,000. You know, since h is how many hours it's been since we started measuring, after 0 hours, there are 1,000 bacteria. That is our starting amount of bacteria. When h is 0, that would still be our starting amount of bacteria. How about when h is 3? So after 3 hours, and every hour, it doubles. So that would be 1,000 times 2 to the 3rd, or 1,000 times 8, or 8,000. And that would be bacteria after 3 hours. There'd be 8,000 bacteria after 3 hours if they doubled every hour. I think that makes sense. So you start with 1,000, and after 1 hour you'd have 2,000, and then it would double again and you'd have 4,000, and then the 3rd hour it would double again, you'd have 8,000. So that makes sense. How about this? The last one is the most interesting. It's when h equals negative 2. So that would be 1,000 times 2 to the negative 2nd. Well, 2 to the negative 2nd is 1 over 2 to the 2nd, or 1 over 4. So this is 1,000 times 1/4. And 1,000 times 1/4 is 250. And what this means in this case is I had 250 bacteria. Now, what does the negative exponent mean? The negative exponent means 2 hours ago. Bacteria 2 hours ago. So in the past, and see how it makes sense that 2 hours ago I'd have 250, and then an hour after that I'd have 500, and then an hour after that I have my starting amount, 1,000. It really does kind of make sense. I hope that helps. Good luck on the homework.